Today's activity, we will be learning length measurement. The purpose of this activity is to practice measuring and estimating length in English and SI units to learn about uncertainty and air propagation. For this activity, you will need to pick 5 objects in the room of various sizes so that you are able to estimate and find the actual measurements in English units and SI units, which is metric. The difference between these two is English uses inches while metric uses centimeters. So I'm going to use 2 objects, one rectangular object, which I have here, and a square, more flat object here. You're going to need a meter stick that I have right here and a calculator in order to complete this activity. So I'm going to first start off with this square object, and I'm going to estimate the size that I feel the length from here to here of this object is. And I'm going to estimate that that would be about 3.5 inches. So from here to here, I would say that that is going to be about 3.5 inches. And this is my estimate. Um, Now I'm actually going to take my meter stick and use the measurements in inches because I'm doing English units first. And I'm going to measure this side of the square to see if I was correct. Unfortunately, I was off by half. The actual estimate is 4. So the actual equals 4. So this is for English units. Now I'm going to estimate this same square and this same side of the square in centimeters. And I'm going to estimate that this side of the square is going to be 10 centimeters in length. Now I'm going to find the actual measurements using my meter stick, but this time I'm going to do it in centimeters. And I am right on the mark. The actual is actually 10 centimeters. So now the next step is going to be finding the uncertainty of the object. And what I mean by uncertainty is the air percentage of my measurements. So how you do this is you find the difference of the two, the English and the SI unit, and then you take the actual and you divide it by whatever the difference is. So it's going to look like this. I'm going to find the difference in English, which is going to be 3.5 minus 4 equals, and this is when your calculator comes in handy. So on my calculator, I'm going to do 3.5 minus 4 equals 0.5. Now I'm going to divide 0.5 divided by the actual, which was 4. And when I do that, my error percentage for my English measurements is 0.125%. That's my uncertainty for my measurements in English. Now, for the SI, which is using metric, which is being converted into centimeters, I'm going to do the same thing. I'm going to take the estimated length, which was 10, minus 10 equals 0. Now I'm going to take 0 and I'm going to divide that by the actual of 10, and hopefully we all know that that's going to equal 0. Therefore, for my SI unit, my uncertainty percentage was 0% because I was right on the dot with my estimated, and my actual was the same as my estimated. Now we are going to move on to the next object, and the next object is this heavy rectangle object. Now this is going to be a little bit different because we have a lot more steps, but they're not that hard to follow as long as you make sure that you're doing everything accurately. So I'm first going to start off by estimating the length, width, height, area, and volume of this rectangle. So I'm going to estimate that the length from here to here of the object is 15 centimeters. So the length is going to be and just to give a heads up, I'm going to use SI units, which means that I'm going to be using centimeters, and I'm not going to use inches because that's the English unit. Now I'm going to estimate the width, and the width is going to be from here to here. Actually, stand a step so you can see the width is from here to here. So I'm going to estimate that the width is going to be 1.5. And again, even if your estimations are wrong, it's an estimate. It's not the actual. Now I'm going to estimate the height, and that's going to be from here to here. I'm going to estimate the height to be the same as the length, which is 15 centimeters. Moving on to the area. going to, so when estimating the area of an object, you have one of two ways you can approach this. You can either do length times height, or you can do length times width. I prefer doing length times height, so I'm going to times 15 times the height, well, the length, which is 15 centimeters, times the height of 15 centimeters, and I'm going to get 225 centimeters as the area of this object. Now, in order to get the volume, the estimated volume of this object, you are going to have to do length times width times height. So, I'm going to use my calculator, and I'm going to take the length of 15 times the width of 1.5 equaling 22.5. So 15 times 1.5 equals 22.5 times the height of 15 equaling the volume of 37.5. Again, this is just an estimated guess of the object. Now I'm going to find the actual measurements of this object. So I'm going to erase all of this. And now I'm going to use my meter stick and find the actual length of the object. And the actual length of the object is 15. Now I'm going to find the actual size, the actual measurement of the width. And the width is actually 4. The height is again 15 centimeters. So in order to find the actual area of the object, I'm going to do this. I'm going to 15 times 15, which is the length times the height. And that equals to 225 as the actual length measurements of this rectangular object. Now to find the exact volume of this object, I'm going to take the length times width times the height. So my length is 15 times 4, and I'm going to use my calculator, and that equals 60. Now I'm going to take 60 times the height, which was 15, and that equals 900. So 900 centimeters is the actual volume of this object. Now, in order to find the error percentage, I'm going to first find the error percentage of length. So I'm going to take my estimated, which my estimated was 15, minus 15, which was my actual. So this is my estimated, and this is my actual. And I'm going to find the difference of the two, which is 0. Now I'm going to divide that by the actual, which was 15, and I'm going to get 0. So for my length, I estimated 15, and my actual was 15 centimeters. So my percentage error is 0. Now, this is for length. Now, for width, I estimated 1 1/2, subtracting the difference of 4. So using my calculator, I'm going to do 1.5 minus 4 equals 2.5. And I'm going to divide that by the actual of 4. And that's going to equal 0.625%. So that is the uncertainty percentage error of width. Now I'm going to do height. So my height is going to look similar to my length because I'm using the same measurement. So my estimated was 15, subtract the difference of 15, and I'm going to get 0. I'm going to divide 0 by the actual, and I'm going to get 0% uncertainty for my height. Now moving on to area. I estimated the area to 225, subtracting the difference of 225 as my actual, and I'm going to get 0. I'm going to divide 0 by my actual, which was 225, and I'm going to get 0% error for my area. Now, moving on to volume. I estimated 337.5 minus the actual, which was 900, and the difference of that is going to be, again, using my calculator, 56.25. Now I'm going to divide that by the actual, which is 900, and I'm going to get 0.625 uncertainty for percentage error of the volume. Now is the time to ask yourself, do you see any trends using SI units versus English units? I can personally say I do see why scientists use the SI system because it's a lot easier and less time consuming rather than English units. So I hope this video is of great use and thank you for watching.